So for the plantation of this question, it's a overhanging beam simply supported at A, roller supported at B. You have to plot the IL for RA, RB, RA, vertical reaction here, vertical reaction here, RA, vertical reaction RB. C is the midpoint of this segment AB. So you have to also plot the IL for bending moment at this point and shear also. Using both method, Muller Breslau and direct method. So in Muller Breslau principle, the basic step are: number one, remove the restraint. Which one restraint you have to remove? For what? लिखा हुआ है. For which IL is to be down. Means for if you are plotting the IL for RA, then RA has to be removed. If for RB is to be plotted, then RB has to be removed. Similarly, if IL for MC is to be plotted, then MC has to be removed out. Okay, MC has been removed out. Has to be removed out. कैसे removed होगा? How it will be removed? By placing a internal hinge. By placing the internal hinge. How shear force will be removed? By placing simply cut. Okay. First step. Second step. Apply unit displacement. Apply unit displacement. Okay. Displacement without direction, it does not have any meaning. Okay. In what direction? You should write apply unit displacement along the direction of restraint. Along the direction of restraints. Along the direction of restraints. What is another? Next step. Plot the deflected shape. Plot the deflected shape. Plot the deflected shape. And which will represent IL. Okay. So that is procedure you have to follow. That procedure you have to follow here. That procedure you have to follow over here. So for IL for RA. Okay. So make a beam at point B. There will not be any change at point B. There will not be any change at point A. What you have to do? You have to apply what? Unit. You have to remove horizontal displacement by providing such type of arrangement. Okay. Here vertical restraint. RA is what? This one restraint. Vertical restraint. So out of vertical and horizontal, vertical restraint has been removed from here. So if you will provide unit displacement, then what? After providing unit displacement, this amount, this value 1. What will be the deflected phase? Since this point is A, this point is B. Yeah. This situation is like, कैसी situation है? It is supported only on one point. Same straight beam, this one, I said. This is supported on only one support. This one that has been removed. Vertical support has been removed by providing this, and we are trying to shift this point to here. We are trying to shift this point in vertical direction only. Okay, so if this point is A, this point is B, and if that point has to be shifted over here, then this beam is going to swing. This beam is going to swing. Swing means झूला, शीशा देखा ना आपने? Just like as शीशा type of thing. It is going to overhang up and down about this single support. Okay, we cannot support any beam. We cannot support any beam at a single point means ये we cannot support कर सकते हैं. We must have at least two supports, two vertical supports. At single support it is not possible. It will swing. Okay, it will swing. Beam has to be supported. Beam can be supported. Beam will be in stationary condition. It will be exactly straight if at least it has to support. At single support, if we will pull in this direction, then it will क्या करेगा? Okay. For downward movement, it will cut everybody here. If we will remove the vertical, okay, that joint, this joint A can be simply treated in this manner also. It is same thing. Okay, it is same thing. This point joint A, horizontal, vertical, and this horizontal. Okay. So when it will go in this, it will have, it deflected shape will have this shape. Okay, and this distance, are you able to calculate? Are you able to calculate? By simple geometry. We know that this distance is total L. This is L by 2. So since this angle and this angle, it is same. Therefore, if this distance is Y, then 1 divided by L. 1 divided by L. This angle theta, इधर का theta, Y divided by L by 2. So value of Y, it will be 1 by 2, 0.5. Okay, so that is how much? 0.5. So this is IL for RA. Any problem? Is it simple? Simple? Okay. Second, IL for which one? RB. IL for RB. Are you able to plot? Okay. Its IL will be treated as how much? In this manner. Okay. Okay. IL for RA, it will be treated in this manner. Okay. This is 0.5 and this is 1. This is the IL basically. Okay. This support, it will not be here. Okay. Means that one diagram is required to you. Similarly, IL for RB. Calculate. So it's simple. It's very simple. B point, this point B has to be removed. Okay. Since, and we have to provide what? Unit rotation. So B point will shift here, B dash, and this distance will be 1. Okay. This B dash will be shifted to B dash. Okay. And since this entire beam, it is supported at only one point, so what will happen? It will, okay. What will be that displacement? Okay. You can calculate from your geometry. So this is the deflected shape. This is the deflected shape. Okay. So simply, if this angle is theta, if this is y, if this is y, y1, so 1 divided by this distance you know very well, it is L. 1 divided by L, 1 divided by L is equals to y1 divided by 1.5L. So y1 equals to L plus L by 2 na? 3 by 2, 1.5. Okay. 1.5. Okay. How many of you make correct? Okay, no problem. Okay. Remove this support. Okay, there is no need to have that support. Okay. It's just only for your imagination. Next is IL for which? MC. IL for MC, bending moment at point C. C is at the midpoint of segment AB. इधर बनाऊं क्या? IL for MC. C point is this. C. Okay. So what we have to do at point C? What should I do? We have to provide. Should I remove any support at A or any support at B? Should I remove? What should I remove? What should I remove? What should I remove? Provide internal hinge at this point. Clear to everybody? Provide internal hinge. We do not have to remove RA or RB. We have to provide internal hinge. And you know very well how internal hinge is to be provided. Okay. It is just this type of situation. It is just this type of situation. Okay. Is it the same thing? Have you provided the internal hinge? Okay. Have you provided? At this point C, so at here, okay, at point C, internal hinge has been provided. Okay. then it has been provided. And what you have to provide in next step? Apply unit displacement. Since moment is this type of, okay, moment causes rotation, therefore theta, rotation will be here, both segment this one and segment this one, here two parts are there, है नहीं? This one first part, this one second, है कि नहीं? Is it there? This is first one part and second one part will be treated as this from C to free. Okay, so it is part 1 and this is part 2. Okay, and if you will provide this type of rotation, then second part is supported at only one support, so it will swing at this, it will swing at this support. Okay, and this one segment also has been supported at only one point, therefore this segment will also have to swing, so if deflected shape can have this type of thing. Is it? यही हो गया? Is it the same thing? Okay. This first part, second part. Clear to everybody? And what are the unit displacements? What is the unit displacement in this case? C point is this, okay, no problem. One is what? C point पर कौन सा मोमेंट है? This value will be, rotation will be, okay, यही पूछना चाह रहा था. This value will be 1. Okay, here rotation will be 1. In case of RA, linear displacement was 1. Okay, here linear displacement was 1, but in case of moment, this will be 1. Clear to everybody? And we must know this value, we must know this one value. Can we calculate? We can calculate from the similarity. So apply this θ1 for this one angle, θ1. Okay, if this angle is θ2, then that angle will be how much? θ2. And we know very well θ1 plus θ2 equals to 1. Okay, and calculation of θ1, if θ1 θ2 are very small, tan θ1 plus tan θ2, tan θ1, if this distance is y2, okay, if this distance is y2, then y2 divided by this L. Okay, so θ1 is y2 divided by L by 2. Okay, no problem, L by 2. Okay, plus θ2, y2 divided by L by 2 equals to 1. So it is the L by 2 ऊपर हो गया, तो 2 by L, y1 plus y2 equals to 1. Okay, so it is y1 plus y2 equals to L by 2. It is y2 na, so it is the double times of y2 into ये 2 by L into 2 equals to 1. So value of y2 is L by 4, 0.25 L. Okay. So y2 value is if that value is known to you, then y3 can also be calculated, and I think it will be same because this one length and this one length is same. So that will also be 0.25 L. Okay. So this is the procedure how you can calculate how to plot the IL using which one? Muller Breslau. Clear? Simple. Last one, IL for shear. IL C point is this. Okay. What we have to do? We have to provide a cut, and shear means this type of disturbances we have to provide. After making a cut, scissor, okay, scissor, फिर cut लग गया, upward, downward. That type of displacement we have to provide at point C. Clear, everybody? This now it has also two parts. It has two parts. This one part, first part. This one part, it is second part. Okay. Second part is supported at only single support, so it will swing at that point. It is also supported at one point. It will also swing at that point. Okay. Make the displacement same. Clear? How it will look like? Is it this? Is it this? Tell me one thing. And suppose it is y1, if it is y2, then summation of y1 plus y2 will be what? Yes. And one more thing is here. Which one thing is? This line and that one line will be parallel to each other, and it will possible only and only when this angle and this angle all have the same value. Clear to everybody? अभी हो सकता है? So deflected shape is this. This is positive, this is negative, this is positive. This point is A, this point is B, it is C. You can write C dash. नहीं, ये which one point was there? Free. No, okay, no problem. C point, C dash, C double dash, no problem. This is the difference. And you have to know the value of y1, y2. Total you know very well, we know very well, it is 1. But how much fraction, how much part of y1 and y2 is that? Okay. So here it will be 0.5, of course 0.5 because it is in between. Okay, but how you have to calculate? If this value is theta, then this also theta. So find value of theta equals to y1 divided by L by 2. L by 2 will be okay equals to, from here y2 divided by L by 2. So from here we can conclude that y1 equals to y2. If y1 equals to y2, then and y1 plus y2 equals to 1. Therefore, y1 equals to y2 equals to 0.5. So both have the same value, 0.5 and 0.5. If this value is 0.5, then what will be that value? Since it is L by 2, it is L by 2. It will also have the same value. So this is the IL for VC. It is the IL for shear force at C. Okay. Complete? Now the same thing we have to do by direct method. So this is using Muller Breslau principle, and next is using direct method. Direct method. Okay. So first one is for RA. First one is for RA. So procedure, you know very well what you should do. What you should do, you know very well. Here it will be RA, and you have to apply unit load. Apply unit load. Okay. You have to basically consider a point load which has the value 1, and you have to calculate this value of RA when this point low is crossing A to B and then B to this point, suppose D. C पॉइंट बीच में था ना, यहाँ पे जरूरत नहीं है C पॉइंट की. Okay, so it will consist of two cases. Okay, it can be value of RA can be calculated when the point load is between AB and when the point load is between BD. Okay, clear? So case 1, when point load is कहाँ पे, when point load is in segment AB, means this type of thing. This situation, 1, this distance x, and we have to find the value of RA. We are interested only to find the value of RA. Okay, we do not need, we are not interested to find that reaction RB. Okay, we are not interested because we have to find only RA. We have to plot the RA. Okay, so we have to take the bending moment at point B equals to 0, so that value of RA can be calculated. At this point, if we will calculate the bending moment, then what we will get? RA into total distance, how much? L. Okay, this one direction. Okay, and another force is 1 into this distance, and this distance will be L minus x. Okay, so what we will get? Value of RA into sigma m about this point is B, na? Sigma m about B equals to 0, then we will get RA into L minus 1 into L minus X equals to 0. The value of RA is L minus X divided by L. Okay, so this is the case number 1. So this is the case number 1. Okay, case number 2. Case 2, where we have to put the point load. Okay, point load has to be placed here, and since we have to plot the, after calculating the value of RA, we have to plot RA, then it is better to take value from here. Let us equate the bending moment here also. What you will get? RA into L into 1 into this distance. How much is that distance?
L by X minus X.
Total this value is L by 2. This is L. Okay, so why you are taking from here? Okay, is it you take value X from here? No problem, we will. Okay, take X. What will be the value? It okay, this is A, this is B, and this is point D. So here this unit load has to be moved from only point B to D, from B to D only, that has to be moved. So it is better to take that X. Why you are taking X from here? Little bit. So equating sigma m about B equals to 0, what you will get? RA into L, okay, minus 1 into X equals to 0. So the value of RA equals to X by L. Got everybody? Equals to this one. Got everybody? Now what you have to do? You have to plot these two. You will get now plottation, and plottation is IL. This point is A point, this point is B point. Okay, so for this segment, what we have? This equation. Okay, R equals to L minus X by L, and for this segment R equals to X by L. Okay, in this case origin point is B, for this segment origin point is B, for this origin point is A. Okay, so when X equals to 0, what will be that value? 1. Okay, and when X is equal to L, it is 0, means here. Okay, and when here, so this is the plot for this segment only. Clear? Clear to everybody? प्लाट इट आंसर। इसमें कुछ गड़बड़ हो गया क्या? प्लस माइनस का गड़बड़ हो गई, प्लस माइनस। यस, इट इज दिस वन डायरेक्शन, ये
प्लस होगा, प्लस
it will have plus sign, then it will have, clear to everybody? That was the mistake. Okay, it has this one and this has same direction of the moment is acting. Okay, so at point B x value is 0. Put here 0 by 0, ये minus done, so it is 0 here. At x is equal to, at point D L का है L by 2, so put it L by 2 by L, what you will have 0.5. Okay, so it will have 0.5. Okay, so this is the shape of, is it the same as we did in Muller Breslau? Is it the same graph? But this is a lengthy, this is the lengthy procedure, this is the lengthy procedure. So prior to Muller Breslau, we are going to we did such type of, used to do such type of things. Get everybody? The same thing can also be repeated for RB, MC and MD. Okay, the remaining part I am giving to you, and now you, class, we have drawn the IL for all these 4 quantities, all these 4 parameters using Muller Breslau principle, and with the help of direct method also we have plotted IL for RA. Today we will plot the IL for RB, MC and VC using direct method, analytical method. Get everybody? What we will calculate, what we will plot today. So for RB, IL for RB, IL for RB. What we should do? What we should do? We should do the same thing what we have done in our last class. This point is A, this point is B. Here reaction RB will be there. Okay, here RA will be there. Our intention will be to calculate the value of RA only. Okay, RB, what is the value of RA? We do not bother, because we are going to plot IL for RB. Okay, and we will, for that we will take a moving load W equals to 1 from this end to this one end. Okay, so here 2 cases will be there, when this point load is in segment AB and when it is in BD. So case 1, when point load is, W equals to 1 is, कहाँ पे? यहाँ पे लिखो, W is in A to B. So put the point load over here at a distance of x from A. Okay, and calculate the value of RB. Calculate the value of RB. Calculation of RB is very simple. How it will be? Equate moment, bending moment at point A equals to 0. You will get RB into this one distance. Okay, how much is this one? Okay, you will get, so that value is sigma equate sigma m about a equals to 0, then you will get RB into L minus 1 into x equals to 0. So the value of RB is how much? X by L. So it is x by L. Case 2. Case 2. When W equals to 1, कहाँ पे? Is in B to D. So we have to put the load where? We have to put the load where? Here. 1 and distance, take this distance as x from B point. This point B, this point A, this point D. And this RB value you have to find. Of course, here it will be RB, RA, no problem, but we are interested to find that value. Okay, we are interested to find only that value. So again, equate sigma m at point A equals to 0. Sigma, so by equating sigma m about A equals to 0, what we will get? We will get हाँ, पहले इसको करूँ मैं RB into L, हाँ, ये this one anti clock and this is clock, so minus 1 into L plus X. So it gives you equals to 0. So we will get RB equals to, yes, L plus X by. Now we can plot. Now we can plot. We can plot. So if this point is A, this point is B, this point is D. For this part, we have RB value equals to X by L, and for this value RB equals to L plus X by L. Okay. For this segment, X origin is A. For this X origin is B. Origin is B. Clear to everybody? For this A is origin. Here B is origin. So when value of X is 0, what will be the value of RB? 0. So this point, we got this point. Okay. At point B, value of X, L. So L by L means 1 plus 1. So we will get this one. And that unit, that value, it will be how much? 1. Okay. Here, and which type of relation? Linear or parabolic? Linear. So straight line, we will get this straight line. We will get this straight line. For straight line, we need only 2 points. Clear? What about for BD segment? At point B, what should be the value of X? 0. Okay, we should not take value of X as L. Okay, because the origin point is not A. Now origin point is only B. So if we are using this, take value of X as 0 for this. So when X is 0, it is L by L 1. We will get the same point. We will get the same point. And when X is equal to L by 2, we will get L plus 0.5. Means 1.5 L divided by L means total 1.5. And if you will take, if you will plot, then its value is 1.5. And from geometry, if you will calculate this angle, okay, what will be that angle? Suppose this angle is theta. What is the angle of theta? Theta will be, say this value is theta 1. Theta 1 will be, how much is that? 0.5. It is 0.5 divided by L by 2. L by 2. So it is 1 by L. Okay. Suppose this angle is theta 2. Suppose this angle is theta 2. What is that value? Theta 2 equals to 1 divided by L. 1 divided by L. So what we are getting here? Theta 1 equals to theta 2. What it means? If this angle and this angle is same, then what it means? This line, if this point is B dash, if this point is D dash, then A, B dash, D dash, it is a straight line. It is the straight line. Get everybody? So this is the required IL for, this is the required IL for positive. Okay. This is the required IL for RB. This is the procedure how to plot IL using analytical method. Okay. And I think it is same as we did using Muller Breslau principle. Okay. The same result was there. Is there any difference? There will not be any difference if we are going to correct. Another is इसका हो गया RA we did, RB we did, MC. IL for next is IL for bending moment at point C. IL for bending moment at point C. We will do the same thing. We will do the same thing whatever we did in previous example, means for RA and for RB. And what we did? Two segment unit load. We have to place unit load in case 1. Okay. Let us see here. This says C point. C point is this. C point is this. And here, suppose this type of bending moment is there at point C. At point C. Suppose this type of bending moment is here. Okay. So, and this point is A, this point is B, this point is D. So, out of this, how many segments we have to consider? How many segments we have to consider for this case, for bending moment at point C? We have to consider this one segment, then we can take this segment, can take this segment. 3 segments we can consider. You can eliminate that segment because it is 1 unit. Because it is 1 unit, but do not, okay, consider individual, you will get the same thing, no problem. Okay. And we have to calculate the value of MC. We have to calculate the value of MC at point C. So case 1, this is basically case 1. Case 1, it is case 2, it is case 3. We will calculate the value of MC. We will calculate this value of MC 1 by 1. 1 by 1. So taking case number 1. Okay. So make another diagram. Make another diagram. This point C is here. This point is 1. And this is X. Okay. So what we are interested to find? Value of MC only. Okay. value of MC. You can consider this segment only. You can consider this segment only to find the value of MC. You can also consider this segment. You can also consider this part. Okay? Which part you should consider? Which part you should consider? You can consider any one of them. You can consider any one of them. Which gives you the correct value. Which gives you the correct value. Both sides will give you the correct same value. You can consider any one of them. यहाँ आप दोनों को करके दिखाता हूँ. So at this time reaction RB, here RA. What will be the value of RB and RA? Can you tell me what will be the value of RB? RB value will be X by L. We did. Okay, this is the same thing now. And what will be the value of RA? 1 minus. Okay, summation of this is 1. So it is 1 minus X by L. L minus X by L. It is the same thing. Clear? So directly we can calculate here. So if we are taking this part, if we are considering this part, okay, if we are considering this part, then what will be the value of this MC? This value MC will be RB multiplied by this one distance. Right, everybody? And that distance is how much? That distance is L by 2. So we will get X by L multiplied by L by 2. Okay. So considering that one part, if we are considering this one part, then value of MC, we got X by L multiplied by L by 2. Means what? LL cancelled out. Okay. So we are getting X by 2. Okay. We are getting X by 2. Is it not? Okay. And from that side, this one side, what we will get? Here, how many forces are there? RA is there, M is there, and MC is there. 3 forces are there. Okay? 3 forces are there. So the value of MC will be RA minus RA multiplied by this. Okay, minus 1 into this one distance, and that distance is L by 2 minus X. Okay, तो चाहे ये वाला काम कर ले या ये वाला काम कर ले, you will get the same thing. Okay, you will get the same thing. So what will be that value? Value of MC equals to RA into L by RA means 1 minus X by L. Yeah. Okay. Into L by 2 minus 1 into L by 2 minus X. Okay. Equate it at. Is it same thing? So it is L by 2 minus, it is cancelled out X by 2, and this is minus L by 2 minus plus X. So that has been cancelled out. So it is how much? We got the same result. Get everybody? We got the same result. So okay, it was simple. Okay, that part of it was a simple thing because it has only 2 RA and only 1 force is there. और ये कितना होगा? जितना इसको ट्विस्ट कराएगा. Got everybody? So this is the value. And this is the case 1. Now consider case 2. Consider case 2. in this case, what we should do? What we should do? This point is C. This point C is here. Okay, and we have to place this unit load. Okay, this unit load, right? And consider this value as X and find this value MC. Find the value of MC. Okay, this is the case. So this reaction RB, what will be the reaction of RB? So value of MC will be what? Here. If this value is RB, okay, then what will be the value of MC? Okay, it will be better to take यहाँ से ले इधर से ले. It will be RA into L by 2. Okay, it is not easier to, it is not इस तरीके. Okay, so this value and calculation of RA, it is very simple. How it can be calculated? Apply M at point here. This point is B. Sigma MB equals to sigma M about B equals to 0. Then you will get RA into L, okay, and minus 1 into this distance. How much? L by 2 minus X, okay. L by 2 minus X equals to 0. So the value of RA is L by 2. हाँ, तो इसको L minus 2X divided by 12. Okay. So value of R is this. And we know very well what is the value of MC. From this side only to take that value. It is RA into L by 2. It is RA into L by 2. RA value you know very well. It is L minus 2X by 12 into L by 2. This L, that L has been cancelled out. So we got L minus 2X by 4. This is the value of MC. Write equation number 2 here. This equation 1. Okay. Now case 3. Consider case. Now consider case 3. Consider case number 3. What you should do? You have to consider. You have to apply unit load where? Means here. Okay. And what should be the value of X? Which point should be the origin? Which point should be the origin? Which point should be the origin? B point. This point should be the origin. This point is B. So take this and unit load will have that value. Okay. And if this value is RB, this value is RA, okay, and here since at point C this type of thing is that, so value of MC will be what? What will be the value of MC? Excuse me. For that case it is RA into L by 2. Okay, so the value of MC here, it is RA into L by 2 from this side. Okay, we are not going to calculate value of MC from this side. If we will calculate, then we will get the same thing. Okay, and what is the value of RA? What is the value of RA? We have calculated this from here. Okay, this is the same thing. Okay, we have calculated the value of RB. So value of RA will be 1 minus L plus X by L. Okay, and it is what? 1 plus X by L. So what will be the value of RA? Only X by L. Okay, 1 minus 1 plus X by L. 1 will be cancelled out. Simply it will be only RA value will be X by L. So we will get value of MC as X by L into L by 2. This L cancelled out. Finally we will got X by 2. Now we can plot. After doing that we can plot. Okay, after doing we can plot. So for the plotation we have this point A, this point as C, this point as B, this point as D. Okay, this is case number 1. Okay, this is case number 1, this is case number 2, this is case number 3. Okay, and value of MC, what we have calculated? Value of MC for case 1, how much is that? Where is that? Case 1 is that, na? X by 2. And for this case 2, L minus 2x by 4. Okay, for this again X by 2. Okay, and we know very well what are the origin point. Origin point for case 1 it is A. For case 2 origin point कहाँ है? C. For it is B. Okay, so it is very simple. So when the value of X is 0, bending moment is 0 at point A, value of X will be 0, so we got that point. Okay, at point C, okay, value of X is L by 2, so put X by 2 and put L by 2, so L by 2 divided by 2 means L by 4. So suppose L by 4 is this point, L by 4 is suppose this point, suppose this is L by, suppose this is L by 4, and it should be straight line. Okay, so this is the plot. This is the plot for segment AC. Okay, now for segment CB means case 2. At point C, value of X is 0. Put here 0. What you will get? What you will get? L by 4 means same point you will get. Okay, you will get the same point. Clear? At point B, what is the value of X? At point B, it is also L by 2. So put the value of L by 2 over here. L by 2, L minus L, 0 means you will get 0 here. Okay, this is the point. This is the point, and since it is the linear relationship, that's why its plotation will also be straight line. Okay, will also be the straight line. Okay. कहाँ पे? माइनस का आएगा, हाँ, तो कहाँ माइनस था वहां पे? कहाँ पे? यस, ये कितनी थी आरबी की वैल्यू? 1 प्लस एक्स बाई एल. ओके, टोटल लोड इज 1, Okay, so RA value will be minus x by L, na? Okay, it will be minus x by L. So it will be, it will be minus sign will be this. Okay, it is minus. Okay, so make that correction. You आपने बताया नहीं था वहां पे. RA value will be minus x by L because the summation sigma f5 should be 0. Okay, now when value of x is at point B, x is 0, put the value 0, you will get the same point. Okay, you will get the same point. Okay, at point D, L by 2, put here, you will get the minus L by 4. So you should not go in upper side, you have to shift in downward side. So L by 4. So L by 4, suppose this is distance L by 4. Okay, so that graph we have obtained. Okay, now find this angle theta 1. What is the value of theta 1? L by 4 divided by L by 2. So L by 4 divided by L by 4 divided by L by 2. You will get, LL cancelled out, 1 by 2. Okay, this value theta. Find this value theta. Suppose this value is theta 2. We do not know whether theta 1 or theta 2 are different because we have two different equations. Okay, so value of theta 2 from here, L by 4 divided by L by 2. What we got 1 by 2. It means value of theta 1 equals to, it means what? It is a straight. It is the straight. Let everybody, and the same graph, same plot, same plot we got in Muller Breslau principle. And Muller Breslau principle gives a very simple, first type of calculation is not required. Such type of calculation was not required. So Muller Breslau principle saves the time while plotting these type of graphs. Clear to everybody? What is the importance? That is the importance basically. This is the importance of having Muller Breslau principle. This is positive and this is negative. You write also. This is positive, this is negative. Muller Breslau principle saves the time. Clear to everybody? Next, you have to calculate you have to also plot the IL for VC. That we did. This one we have to plot. Okay, we have to plot the IL for VC. So next is IL for okay. Any doubt to anybody? All clear? आ गया? अच्छा जबरदस्त नहीं है? क्यों? थोड़ा बहुत आ गया, एक्सपेरिमेंट हो गया, पहले क्लास में इतना हो गया. ओके, नाउ IL फॉर VC. VC is shear. Okay, VC is shear. So what we should do, you know very well. Okay, what we should do, you know very well. C point is this and this is force, this is force, this is VC basically. Okay, this is VC. You have to find that value. You have to find that value. For this segment, make a cut over here. Okay. You have to find this value. VC. This one part VC. You find this value. No problem. Take any one part. Take any one part. Okay. When this point load W equals to 1 moves from this end A to B and B to D. Therefore, you have to consider how many segments? How many segments you have to consider? You have to consider this segment, this segment, this. You have to consider these three cases individually. Okay? Individually, you have to consider these three cases. Just like as for MC. Bending moment at point C. In the same manner, you can plot. Okay? Shear, it is the vertical force. No problem. Okay? So consider the case 1. Consider case 1. Consider case 1. So case 1 is, for case 1 we have to place unit load here and value x should be that. X should be this value. Okay? And remember what we need. We need this force. Okay? So this value is RA. This value is RB. Okay? And what will be the value of VC? Is it RA? Okay? If we consider that, then what will be the value of VC? RB. Clear to everybody? And you have calculated the value of RB. How much? How much value you have calculated? For that case, calculate कर चुके? It is x by. Okay. So the value of VC comes to be x by. Is it minus or plus? This is minus or plus? Plus. Okay. Case 2. In case 2, we have to place the point load where? Here. Okay? And this should be considered as x. Now you have to find this value. Okay? So this reaction RB, this reaction RA. Okay? What will be the value of VC? It is RA. Okay? For equilibrium you will get RA. Clear to everybody? What will be the value of VC? It is simply consider this part. Okay? If you are considering this part, then what you will get? Downward है ना? 1 minus RB. You will get 1 minus RB. Get everybody? So value of VC for this case it is RA, and you know what is the value of RA? बताएं, कर चुके ना इसका? How much is that value of RA? How much is that? बताएं. 1 minus x by. Is it the same thing? Is it 1 minus x by L? Tell me. Correct? Now consider case number. Consider case number 3. 3. So in that case, where point load should be placed? Point load should be placed here. Okay, point load should be placed here, and x should be this distance. Okay, and C point is, since C point is this, C point is this, so this should be the, okay, so this is RA, this is RB. What will be the value of VC? Which one part we have to consider? This one part. And what will be that? Value of VC equals to minus summation of, क्या होगा? Summation sigma phi equals to 0. What you will get? What you will get? Up plus side RA plus VC equals to 0. क्या कर रहे थे यहाँ पे? ओके, यहाँ पर भी गलत किया क्या? ओके, सो हाँ, कौन सा किया था? फर्स्ट केसेस ये पार्ट लिया ना? हाँ, तो देखे डाउनवर्ड अपवर्ड. ओके, सिग्मा फाई इक्वल्स टू 0. दिस वन, इसमें कौन सा लिया? इसमें दिस वन पार्ट. ओके, तो ये वैल्यू माइनस होगी. हाँ, 1 minus x by l, so it will be minus, means what we will get? X by l minus 1. Okay, x by l minus 1. Similarly here, value of VC we will get. What is the value of RA? Minus RA, and RA is, how much is RA? How much is RA? 1 minus क्या माइनस एक्स बाई एल था ना? इट वॉज द माइनस एक्स बाई एल. देखें, ओके, सो वी सी इज माइनस इंटू माइनस एक्स बाई एल, इट मीन्स एक्स बाई एल. Okay, now you can plot the value. If the reaction values are correct, then you will get the correct shape, as we did in case of Muller Breslau. Right, everybody? So make that figure. Let us plot. Let us plot. This is case 1, and for case 1, value of VC is x by l. Here x by l minus 1. Here minus x by l. केस 3 में ओके, एक्स बाई एल. ओके, सो हियर वैल्यू ऑफ VC इक्वल टू 1 माइनस ये माइनस टाइम्स ऑफ 1 माइनस एक्स बाई एल. यू राइट दिस इन दिस मैनर, 1 माइनस एक्स बाई एल. ओके, सो लेट अस प्लॉट. स्टार्ट द प्लॉटेशन. At point A, value of x is 0, means we got this point. At x is equal to C, Value of x is L by 2. Put the value of here. What you will get?
0.5.
L by 2 divided by L 0.5. Okay, you will get point. वो भी plus का. Suppose this is 0.5. Okay, what will be the shape? It will be the straight line. Clear? Similarly, here at point C, x value of x is 0. हाँ, यहाँ पे कुछ गलत बताइए आपने. 1/2 आपने मुझे दिस वैल्यू ऑफ आर ए इट इज नॉट करेक्ट. वैल्यू ऑफ आर ए कितनी है? 1/2 एक्स बाई एल. बताया क्यों नहीं आपने? आप अपना अपना जब पूछे तब बताएं. और पता नहीं, आई डू नॉट नो whether this value is correct or wrong. आवाज करने में तो खूब आगे कर चुके हैं, ये सेम कैलकुलेशन कर चुके हैं. तो कितना हुआ यहाँ पे? आर ए ये इक्वल टू माइनस था ना, ये माइनस 1/2 माइनस एक्स बाई एल. सो हियर माइनस टाइम्स ऑफ 1/2 माइनस एक्स बाई एल. जबरदस्ती चीजों को नहीं करें. ओके, आप बताएं मुझे जहां पर भी डाउट है. आवाज मचाने में तो बिल्कुल नहीं सोचते हैं. आवाज मचाने में तो हल्ला काटने में बिल्कुल नहीं सोचते हैं कि सर को बुरा लगेगा नहीं लगेगा. गलत चीज यहां पे लिख रहे हो, बता भी नहीं रहे. Okay, so please put it at point C. Value of x 0. So we will get minus 1/2 means minus 0.5. So minus 0.5 means we have to shift here. It is 0.5. Okay. At point B, value of x is L by 2. Value of x is L by 2. So put here L by 2. divided by L 1/2. 1/2 minus 1/2 0 minus 0 doesn't mean, it means this is okay, and this. Okay, for this segment value at point B it is 0. So x by L means 0. You will get the same point over here. At point D, value of x L by 2, put here 0.5. So 0.5. This value is 0.5. Okay. Since this distance and this distance is same, and since this ordinate it is same, what it means? This angle and this angle it will also be same. That's why it will be the and you join this. Okay, join this. Okay, if you find this theta, okay, theta 1, theta 2, suppose theta 3, then you will get theta 1 equals to theta 2 equals to theta 3, and it will be same 0.5 divided by L by 2, 1 by L. Anyone? 0.5 divided by L by 2. This one 0.5 divided by L by 2. This 0.5 divided by L by 2. Okay. The same graph, same plot we obtained in Muller Breslau. Okay. So this is the procedure, analytical procedure, how you can calculate the things. And here you are observing that this analytical approach is time consuming. And it is also, if we did any mistake, then it will give the wrong result. Okay, such type of thing. We did a mistake in calculating the value of the reaction and we will get the correct wrong result. Okay, यहाँ तो हमने कर लिया, लेकिन कभी ऐसा भी हो सकता है कि in Muller Breslau that graph was very simple to plot. That graph was very simple to plot. Okay, thank you.